there are some important points that we want to discuss here. Those points are, let us first consider when limit x approaching a, f of x plus g of x and that exists. When f of x plus g of x का limit exist करता है, so we have certain points that we want to discuss here. The first point is कि अगर f of x plus g of x का exist कर गया तो हमारे पास क्या क्या option हो सकता है. What are the options that we want to discuss here कि इस केस में हमें वो लिमिट एग्जिस्ट कर सकता है और इस केस में हमें वो लिमिट एग्जिस्ट करता हुआ नहीं मिलेगा. तो जो फर्स्ट केस इज कि जब हम f of x और g of x both at x approaching a एग्जिस्ट करता है, exists and limit x approaching a, g of x also exists. When both the limit of f of x and g of x separately exists, then it is obvious that limit of f of x plus g of x when x approaches a also exists. That is the first case. There is no need to prove this one. It is very simple and obvious. So let us come to the second point. The second point says कि ऐसा भी हो सकता है कि जब दोनों एग्जिस्ट ना करें तब भी हमारे पास एग्जिस्ट करने का चांस है. देखते हैं. That says when limit x approaching a, f of x does not exist, and same is the case with g of f x. Limit x approaching a, g of x also does not exist. अगर both exist नहीं करते हैं तो क्या ये ऐसा हो सकता है कि f of x plus g of x लिमिट एग्जिस्ट करेगा? देखते हैं. एक एग्जांपल लेते हैं. f of x be the function g f of x and g of x be the function fractional part of x, and we already know that x equals to fractional part of x plus greatest integral part of x. So when we take the limit of f of x plus g of x, then it would be like, it doesn't matter whether we approach x to 0 or to infinity or to some other number, it doesn't matter really. So x tends to a, that will be equal to g f of x plus fractional part of x when limit x approaches a certain number a. So when the certain number is approached by x, so g f of x plus fractional part of x, both the addition will give x, and we already know limit x approaching a x will be a. So the value of limit x approaching a, f of x plus g of x, where f of x is equal to g f of x and g of x is equal to fractional part of x, equal to a. That is the final answer, and this is a finite number. So when both the limit does not exist, it can be possible that some of them exists. It is not the case that always it will happen, but there is an exception, and this one is an example for that. So what we can say कि अगर लिमिट f of x और g of x का दोनों को अगर हम एडिशन ले, f of x and g of x, उन दोनों का एडिशन का अगर लिमिट एग्जिस्ट करता है तो हमारे पास दो केस है. फर्स्ट केस है कि दोनों का लिमिट एग्जिस्ट करेगा, या तो फिर सेकंड केस में क्या हो सकता है कि दोनों का लिमिट एग्जिस्ट नहीं करेगा. बट थर्ड केस कि जहां पे एक का लिमिट एग्जिस्ट करता है और दूसरे का नहीं करता है, लेट्स से कि f of x का एग्जिस्ट करता है एंड g of x का नहीं करता है, उस केस में हमको 100% उसका लिमिट एग्जिस्ट करते नहीं मिलेगा. That means when one function is in case of one function the limit does not exist, and in case of another function the limit does exist. That means एक फंक्शन का हमें एग्जिस्ट करता हुआ नहीं मिलता है तो दूसरे फंक्शन का एग्जिस्ट करता हुआ मिलता है. तो जब हम उनका सम लेते हैं तो फाइनल जो रिजल्ट है वो हमको लिमिट एग्जिस्ट करता हुआ नहीं मिलेगा. Okay, so these are the 3 points. The 2 of them I have included here, and the third one I have discussed. Now let us come to the second case. Second case says limit of x tends to a f of x multiplied by g of x. If we consider limit x tends to a f of x multiplied by gx, then can we say that the both fx and gx should possess the limit, yes, the limit of both the functions should exist? Let us discuss that. अगर ये एग्जिस्ट करता है तो हमारे पास पॉइंट्स है क्या क्या, ये या तो बोथ एग्जिस्ट करेंगे, दैट इज द ऑब्वियस केस कि अगर बोथ एग्जिस्ट करते हैं तो उनका प्रोडक्ट भी एग्जिस्ट करेगा, दैट वी ऑलरेडी नो इन अलजेब्रा ऑफ लिमिट्स. लिमिट x tends to a f of x exists and limit x tends to a g of x also exists. So in this case it is obvious that product of them will also exist. Now the second point says the limit x tends to a f of x exists and limit x approaching a g of x does not exist. इस केस में भी हमें ऐसा मिल सकता है कि प्रोडक्ट ऑफ देम ऑल मतलब एग्जिस्ट करेगा. व्हेन वन फंक्शन डज नॉट एग्जिस्ट एंड अनदर फंक्शन एग्जिस्ट इन केस ऑफ लिमिट, सो प्रोडक्ट ऑफ देम कैन आल्सो बी, ऐसा हो सकता है कि प्रोडक्ट ऑफ देम एग्जिस्ट करता है. लेट अस कंसीडर एन एग्जांपल. लेट f of x be x, simple x, identity function, and g of x will be 1 upon sin x. And we are considering the limit when x approaching 0. When x approaches 0, f of x, that is x, will be simply 0, and when x approaches 0, g of x is simply infinity. And when we really consider the LHL and RHL of g of x, then we come to know that RHL will be infinity and LHL will be minus infinity. So the limit here does not exist. So LHL equal to minus infinity and RHL equal to infinity. That says the limit of this does not exist. Limit when x approaches a g of x does not exist. But product of them, that is f of x into g of x, which is x upon sin x. If we consider limit of this product when x approaches 0, that is limit of x upon sin x when x approaches 0, this will be equal to 1, that we already know from the formula of limit x approaching 0 sin of x upon x. If that is equal to 1, so this has to be equal to 1, which is a finite number. If these two like that के f of x का exist करता है limit and g of x का limit exist नहीं करता है at a certain point x equal to 0, but still their product ऐसा होता है कि उसका limit exist करता है उस point पे. So this is the counter example for that. So it is not necessary कि अगर एक फंक्शन एग्जिस्ट करता है और दूसरा फंक्शन एग्जिस्ट नहीं करता है तो उनका प्रोडक्ट एग्जिस्ट ना करे. ऐसा भी हो सकता है उसका प्रोडक्ट एग्जिस्ट कर ले और ऐसा भी हो सकता है उसका प्रोडक्ट एग्जिस्ट ना करे. नाउ कम टू द थर्ड पॉइंट. इन द थर्ड पॉइंट ऐसा लेते हैं कि बोथ द लिमिट डज नॉट एग्जिस्ट. लिमिट x अप्रोचिंग a f of x and limit x approaching a g of x both does not exist. चलो एक एग्जांपल लेते हैं. we will understand in a better way by taking an example. Let f of x equal to 1 when x less than 0 and 2 when x greater or equal to 0. This is a piecewise function and so do gx. Gx is equal to 2 when x less than 0 and 1 when x greater or equal to 0. देखो अगर हम सेपरेटली इनका लिमिट कंसीडर करते हैं तो एट द पॉइंट x इक्वल टू 0 both fx and gx का लिमिट एग्जिस्ट नहीं करता है, but when we take the product of both functions, that will be simply 2. It doesn't matter whether we consider x less than 0 or x greater or equal to 0. In both the cases, the product will be 2. Here consider when x less than 0, this is 1, and when x less than 0, g of x equal to 2. So product of them will be 2. And when in case of x greater than equal to 0, f of x equal to 2 and g of x equal to 1. In this case also, the product of them is equal to 2. So it doesn't matter whether we take x less than 0 or greater than equal to 0. In both the cases, f of x into g of x will be equal to 2. Now limit x tends to 0, f of x into g of x, that is equal to 2. Since it is a finite number, the limit of them doesn't matter when at which place we are taking, it will be simply 2. So here the limit of both the function does not exist till product of them possess a limit at x tends to 0. So this can also be a case. So हमने पढ़ा कि जब एडिशन होता है उसके और सम ऑफ टू फंक्शन का लिमिट एग्जिस्ट करता है एट अ सर्टेन पॉइंट, देन टू केसेस आर देयर. The first one says कि both the limit will be both the limit exists, and in the second case we say both the limit doesn't exist. And sorry, तो इन केस ऑफ प्रोडक्ट ऑफ टू फंक्शन हमारे पास तीन केसेस हैं. फर्स्ट केस बोलता है कि बोथ द लिमिट एग्जिस्ट करता है. सेकंड पॉइंट ये कहता है कि एक फंक्शन एग्जिस्ट करेगा, एक फंक्शन का लिमिट एग्जिस्ट करेगा, दूसरे का नहीं करेगा, तब भी हमारे पास प्रोडक्ट का लिमिट एग्जिस्ट करते हुए मिलेगा. थर्ड पॉइंट से कि बोथ लिमिट f of x एंड g of x का अगर एग्जिस्ट नहीं भी करेगा तब भी हमारे पास ऐसे फंक्शंस हैं जिनका प्रोडक्ट हमें लिमिट एग्जिस्ट करते हुए दिखा देगा. थैंक यू.